Hello, everyone. So my first question to you is it fair for me to assume that this was both interesting, what you just saw, reassuring in one part, but also a little bit terrifying? Good, good. That's a good thing to have in mind. The idea is that what you saw earlier is true. It is a promotional video. It looked like it, and it is. But it's also 100% true. This happened, or this video is about 1 year old, but I was comfortable living in the 1 month ago part because I'm certain that somewhere in the world this is accurate today. Something similar happened 1 month ago, we just don't know about it. And that's a good thing. The fact that we don't know about it is a good thing, because when we find out about things like this, that means something really, really bad happened. Now, before we start, I want to answer one question, which I think all of you have. What will I learn after watching this talk? And the answer is that there are 3 main ways we can be in a cloud-native way of working. The most common one is using public cloud providers. We all know about Google, we all know about Amazon, Microsoft, and so on and so forth. The second way we can do things in a cloud-native way is for companies like ours to actually deploy a cloud-native solution within their own infrastructure and offer SaaS to their clients. But there is a third way, which is not that common in our industry. And that is actually deploying cloud-native solutions on-prem. And today, I'm going to one-up that already difficult situation with doing this also in air-gapped environments. Now, in this talk, I will take you on a journey that will show you the steps that we took to migrate from legacy code to cloud-native solutions deployed on-prem, and all the hoops that we had to jump through in order to do that in an air-gapped environment. And if the last part of this sentence doesn't apply to you, don't worry. Most of the steps and most of the slides and everything that I will present will apply to the first 2 approaches as well. Now, we all know that cloud native is more an idea, a solution, not so much a product, right? But I did make that the first sentence in my title. And it's okay, it's just a play on words, and I'm sure that by the end of this presentation you will understand why that is the case and why that holds water. Just a little bit about myself. Hi, I'm Liviu Spiroiu. I'm a Java team leader, but I'm also a Scrum Master, and I've been working at Cognite for about 1 year and a half. You can see all my contact information there. I'll have the same slide at the end. If you want to ping me afterwards, feel free to do that. And I'm here today to bridge the gap between software development, microservices, security, cloud native, and everything in between. And I'm actually glad that my talk is at the later half of this conference, because honestly, after watching all of these amazing talks, I think this will be a great summary of most of the things, or at least most of the important things that you also heard here during these 2 days. And if the presentation seems to lack specifics, and by specifics I mean versions, tool names, and so on and so forth, that is actually done on purpose. I don't want to do network fingerprinting and OS fingerprinting for free. So therefore, if you need to ask more specific questions, feel free to find me afterwards and my colleagues here at the Cognite booth. But before we go any further, let's explain the title a little bit. Now, sometimes there is a confusion that cloud native is Kubernetes. Well, it's not. Cloud native is not containers, cloud native is not a cloud provider, and it's not even a technology per se. And being not cloud native actually means implementing the practice of accelerating your business by not running stuff that doesn't differentiate you. This is a quote or an idea I stole from Justin Garrison. Now that translates into actually deploying your infrastructure once, and then if you're a software company, focusing on the things that make you great. Focusing on the things that make your company something better, something new, something different. But when the cloud is also part of what you deliver, well, the actual cloud solution does differentiate you. And that is when things get a little bit interesting, to say the least. And that is why I'm using cloud native as a product, as a term to coin in this presentation. On the other hand, an air gap is basically a security measure that isolates a computer, network, or in this case, a cluster, and prevents it from connecting to the outside world. This is just a fancy way of saying isolation. But if you bring both of them together, what it actually means is deploying a cloud solution from scratch, on-premise, in an isolated environment. And I can see a little bit, just looking through the audience, that this makes some wheels turn. How is this possible and how we can do that? Now, in today's agenda, we'll be talking or answering three main questions. The why, which, as we saw in Venkat's presentation, is the most important thing, but also the how from a technical standpoint, and the why not. Now, in order to go through the why, there's also a social aspect. And for that, I will just play one more video for you.
The head of investigations at the European National Security Organization had a problem. Investigations were taking too long, eating up way more time than they used to. In many cases, they took months to conclude. Sometimes they took years, and even then failed to reach a conclusion or provide actionable outcomes. Their main problem was their technology was outdated. The tools the investigative teams were using were no longer fit for purpose.
After the Cognite platform was deployed, their investigation team received a lead that a radical group was planning to drive a large vehicle into a crowd of people in one of its main cities, but they had no intel on who the perpetrator might be. Using the Cognite platform, they had already identified activity on social media and on the dark web that pointed to a similar potential threat and people who might be involved. Our platform fused and analyzed massive volumes of data sources, including web and social data, as well as government databases such as vehicle registry and criminal records. The analytical model dynamically mapped potential suspects based on behavioral analytics and anomaly detection. Things like history of radicalization, travel to certain countries, and reports on vehicle thefts.
Once a list of potential suspects had been identified, the platform automatically ran a link analysis that revealed 5 of the 7 suspects were connected.
This suggests they were working as a part of an organization group to carry out the attack. Using our platform, the investigative team was now able to gather the evidence they needed to arrest the suspects and prevent the attack.
Now, I know this is a technology conference and the focus should be on tech, and I promise this was the last quote-unquote promotional video that I showed. Every other slide will be technology focused. But the reason I chose to show these videos is for you to understand that for us, going forward, the problem that we tried to solve was the main reason why we decided to go and approach cloud native in the way that we did. So the coupling between the solution and the problem is really, really highly tight. Now, there are 3 reasons why I showed you this video. First of one is, of course, to understand that we are working with government security organizations and law enforcement agencies, but also the second one was for you to understand a little bit what the challenges are. And one of those is the fact that existing solutions are slow and old. And number 3 was to understand how crucially important it is for us as software developers, architects, DevOps engineers, and everything in between to get it right, and what the impact is if we don't. Now, that was all nicely tied with a bow, but when it comes to the infrastructure side, now switching to technology as promised. The actual goal was this. Click once, go for coffee, 2 hours later, log in and start working. Now, it doesn't matter how simple or complex the actual solution is. What it really matters is that everyone wants the Windows installer experience. Start, next, next, finish. And that's easy to do if you deploy a standalone desktop application. It's not that easy when you're talking about a full cluster and a full on-prem cloud solution. So, the main challenges that we have to overcome is, first of all, identifying the hardware, installing the OS, deploying the actual cluster, then deploying our own solution, and on top of that, making sure that at every step of the way, we basically respect all the best practices, both in the software development area and also in security. But after getting a general sense of what we wanted to do and what already is out there, we did have to focus on our own technology. But even before we started going to the cloud solution, we had to answer for ourselves and for everyone else the question of why rewrite the software and migrate to microservices? It's working, right? We can keep it as it is. And I like to answer this question with 3 more questions. Can any of you tell me if you have ever heard about COBOL? Please raise your hand. Okay, great, off to a good start. How many of you have written or know how to write code in COBOL? Thank you, and wow. Okay, for everyone else who didn't raise their hand at the second question, are any of you interested in actually learning and writing code in COBOL? Please take a look around you. And that's the actual problem. Now, according to Reuters, now, in 2023, there are still 220 billion lines of code still in production. And every day, those lines of code manage 3 trillion in daily commerce. If that's not scary for you, well, for me it is. I'm losing sleep when it comes to this, because if we extrapolate this, and by the way, all of these stats are in the US only. Don't think that the rest of the world is using the latest and the greatest. That's not the case. It's the same system distributed around the world. So again, if that doesn't scare you, okay. The whole point of this slide and the whole point of me showing this is the fact that I consider that this can turn into a crisis if it hasn't already ASAP. And the reason for that is that the people, and you just saw it here in this room as well, the people who know how to write code in COBOL are either retired, some of us are still here, but others are just planning on retiring, or basically they are dead. Because this is a 63-year-old or 64-year-old programming language. And it's still running our whole financial sector. And with no offense, I really appreciate it. You are one of the heroes, the unsung heroes. Generally, I rarely see a hand raised to my second question. And the idea is that, well, again, this runs our life. Everything drips down to money. So what happens if we don't have developers that can do this? Taken into the extremes, this can actually mean the collapse of the financial system. But this is not only happening in the financial system, this is also happening everywhere else we have legacy code. And this slide for me is a call to action to everyone. It's our responsibility as developers, leaders, architects, government officials, and everything and anything to basically make sure that this will never happen again. And in order to do that, we have to have a 2-pronged approach. Number 1 is to focus now our time, our energy, and our mental capacity to rewrite and refactor everything that we can to bring it up to standard. But the second one is to actually choose an architecture going forward that works, is scalable, but it's also technology agnostic. Right? The whole point of that is to be free going forward. Things will change, but our architecture should be able to allow that to happen without breaking down the whole application. And this segues perfectly to the second question, why cloud and why cloud native? Now, in the past, security organizations invested a lot of money and effort to get even the little bit of information that could give them an edge. Nowadays, this is completely opposite. Data is not the problem. The problem is actually sifting through all of this and get some insight and get some meaning that can be actionable. Feel free to read the quote from the Chief Information Officer of the CIA. It summarizes what I just said. But more importantly, please take a look at this chart. Now, according to Statista, it is expected that in 2024, we will be transferring to our networks around 149 zettabytes. My mind doesn't even compute that. I don't know how much that is. It's humongous. We have social networks, messaging apps, databases, videos, images, and a lot more that really need to be processed. And this is the key word, in almost real time. In real time, if we can do that. And doing this on demand, basically using a standalone approach, is impossible. So we need scale. If we need scale, we need cloud. Now, the third and last question you might ask yourselves or even ask me afterwards is, why air-gapped and why on-prem? Sounds complicated, but the answer to this is the most simple that I can give you, because we had to. Working with governments and security organizations, we had to obey a humongous set of rules that was not negotiable. And those rules are focused on the ownership of data, privacy, and the security of the information that they store. Therefore, the first two approaches, online and SaaS, were discarded from the start. So we are left with this. And now we will be switching to, I think, the most interesting part for everyone in this room is the how. The how and the steps that we took. Now, even though our end product is a cloud-native solution delivered on-prem, as previously said, the thing that fully differentiates us is the investigative analytics. But we had to focus on both. Now, deploying the cloud infrastructure at the same time while migrating all of our legacy code was challenging, to say the least. Now, but even before that, we have seen 2 talks now about security, so feel free to go back on those because they are way more in depth. But I'm glad to see that this comes into play together. We started everything with security in mind. And the first thing that we had as a foundation was security by design. Now, as you can see, the premise behind SBD is that security must be built into the development process from the beginning rather than being added later. And while this is by no means a new subject, I think it's been a thing since the beginning of the internet, it seems like everyone thinks about it a little bit differently. Each company, each person has some wiggle room to actually decide what this means for them. For me, and implicitly for us, I see this as deploying and designing the infrastructure, the CI/CD pipelines, the whole architecture in a way such that it can be really hard, hopefully impossible, to actually write code with known vulnerabilities or deploy things in production in an unsafe manner. And the principles behind the SBD segue perfectly to another important concept, SSDLC. Now, we all know at least the lower part of this diagram. We all recognize the steps of the software development lifecycle. When it comes to, but if we map them with security at every step, SDLC turns into SSDLC. So when we gather the requirements and the analysis, we do a risk assessment. When you go into the design phase, you get threat modeling and design review. Now, in the development, where I think most of us focus our time, it is imperative to have static analysis, or SAST, and you saw the talk from Brian earlier in depth with that, but also code review. When you switch to the testing phase or the QA phase, that needs to switch to Dust or dynamic testing. And in the end, when it comes to deployment and maintenance, the security focus shifts to securing the assets and the configuration. And this needs to be a loop. This doesn't have to stop when you reach here. Every time you get a new requirement, the whole cycle starts all over again. So everything is everything is tightly done. We have everything written down. So on the development side, we started breaking down monoliths into microservices and completely rewriting the smaller services if we could. I want to unify quickly the terminology. I won't go too deep into this slide because I'm quite sure that almost everyone is aware, but just in case you aren't, a monolithic architecture is basically a standalone deployment of an application. And it has some benefits that you can see there, but those benefits stay true only if the application and the data that is processed stays small, is small, and stays small. If not, then we shift to a new paradigm, which I'm sure it's something that everyone here knows. And switching from monoliths to microservices architecture has a lot of benefits, including continuous delivery and deployment, but also the fact that each microservice is really small. That's a big win for adding new team members to your team and having them focusing on the small part that is that service without having to understand the full behemoth that is your application. It also brings improved fault isolation, but the last one here circles me back to the COBOL example. No long-term commitment to a technology stack. This is really, really important, and I cannot stress this enough. Now, cloud-native architecture refers to a cloud-based, containerized, distributed system made up of cooperating services. Now, while the developers were focusing on the legacy code, and well, in parallel, a completely new infrastructure was set in place. You can think about this as someone shooting two bullets at the same time, theoretically looking like they go in parallel, but with a shift 1 degree angle, they will meet up at some point. And you can imagine the sparks that created. Actually, making this work, I think, was the hardest part that we had to overcome. But we did. And while now everything integrates seamlessly, please, if you take this approach, account for that. That's all I can say. But in order to meet our initial goal, which was a one-click installation for our infrastructure, that meant, well, IAC. Now, IAC, or infrastructure as code, has a lot of benefits like speed, consistency, efficiency, and what matters to management and clients most, lower costs of infrastructure management. But for us as developers and also for the DevOps infrastructure people, what that meant is basically the infrastructure takes the form of code. And that was immensely important when it comes to both owning the code, maintaining the code, editing the whole configuration, distributing that, and in the end, on our journey to that one-click goal, this meant that the cloud infrastructure was actually provisioned by software instead of manually being deployed. This was the only way this can be made possible. Now, the way we do that is basically using Helm in Git repositories and then ship that out through the mechanism that we had to develop to bypass the idea of air gapping. For those of you which are not familiar with Helm, I will keep this as short as possible. Basically, Helm is a set of YAML files. These YAML files are wrapped in a chart. You can consider that this chart is a package, is a Helm package. You can compare that to Homebrew or DPKG or RPM or whatnot. When you execute or run the Helm install or the Helm updates, basically this installs these charts into Kubernetes and creates a new release for each installation. I'm sure this is not news, but I want to go through it because I think it adds a little bit of a push for those who are still clinging to the idea that VMs are better in a cloud environment or in a cloud deployment. And to move fast but still give an example about this, we have two important or even three important aspects to discuss. First of all, when deploying VMs, once you've allocated the memory, it's done. Even if it's not used, you will waste around, for this example, same server 7 gigs. On the other hand, when you have containers, the memory is allotted, but it's not actually used and deployed. Therefore, I can use the difference between the two to actually scale more if I have to. The second one, as you saw in the previous diagram, the second one is startup speed. Now, when we are talking about almost real-time processing, the idea of waiting for a full-fledged OS to boot, which is what happens when we have VMs, is almost unacceptable. On the other hand, because of the fact that the containers are sharing the kernel, at least, of the host OS, everything else happens really, really fast. So you can spin up as many containers as your infrastructure allows. And the last point is the actual infrastructure integration between VMs. Now, I'm not saying it's hard to do, but it's way harder than defining or running a few command lines to make the VMs talk with each other. Now, really quick left and right. Docker and Kubernetes are the best in class when it comes to containerization. And I still hear in 2023 parallels being done between them as if they are competing against each other. And if there's at least one person that still thinks that in this room, I want to clarify it as fast as possible. Dockers mean containers, which are basically processes that are run at OS level. And they have a lot of benefits like easy and fast configuration, they increase productivity, but most importantly, when it comes to security, they allow more fine access to that, and they offer application isolation. On the other hand, Kubernetes automates manual processes when deploying, but also has inherent load balancing and self-healing, and we will get back to this a little bit later, offers storage orchestration. So when they put them both of them together, there are some context questions that we ask ourselves. Who is coordinating and scheduling those containers? How do you do an upgrade without an interruption of service? And how do you monitor everything else that's happening? Well, this is where the magic happens. Kubernetes was built for this, especially in the beginning, the orchestrating and scheduling part. So to sum it up, Docker is a container technology platform that offers containerization, while Kubernetes is a container orchestrator for a platform like Docker. So we went with Kubernetes. Now, I won't tell you which specific provider of the Kubernetes solution we are using. I said the reason why before. But it is a Kubernetes solution. So one big advantage for our use case was the fact that a self-hosted Kubernetes version offers the owner full control over the cluster. Of course, it reduces the time to deploy, and it allows for CI/CD, zero downtime, and continuous deployment. But the last two are, again, real important. When it comes to having a system that needs to be with hopefully 100% uptime, the last two on this list were mandatory. So, on top of that, everything drips down to money. We all know that when it comes to business and when it comes to clients, money is one of the most important factors when making a decision. So the fact that due to that scalability on demand and the approach that Kubernetes takes, a high utilization of hardware was really important on cost saving. But again, the last two were the most important for us. Kubernetes is provider agnostic. And the reason why this matters so much is that our biggest issue to begin with was the fact that our monolithical applications were optimized to work with specific vendors, specific storage solutions, and specific network equipment. And when we would try to deploy those solutions in an already existing data center, that's when the clashing began to happen. And in order to make the solution work, there is or was a lot of customization involved and a lot of sweat, blood, and tears. So a solution that is provider agnostic was mandatory going forward. Also, we all know that when it comes to security, the last thing you want to do is actually reinvent the wheel. And while for each use case there is some tweaking when it comes to security, using the inherent security that exists in Kubernetes was a big win for us. Now, I had a longer slide on this, but the talk yesterday from Co and from Mary was perfect, so thank you for that. If you have more questions, you have him in the last row. We actually considered Pulsar, and we did a left and right, but for our use case, when it comes to on-prem and in an isolated environment with a somehow limited approach, stability and reliability was really important. And while all of these are true, when deployed on-prem, this was a decision that will have a long-standing effect, and basically changing this in the future would be almost impossible. So we started this why chapter with security, and we will end it with security. And this time in cloud native. Now, in my opinion, and in the solution that I'm presenting, we need to have security at every level. When it comes to container security, I will just name a few. Of course, there are many, many more. Make sure you apply the least privileges concept, which basically means don't run as root. Try to have different container IDs if possible. Not all. Usually, most of the containers don't actually need write access to the file system. You can disable by configuration the privilege escalation option. Then at pod level, leverage pod security contexts as much as possible. Define security policies, define network policies, and use pod service accounts if you need to and if it's possible. At cluster level, well, basically, I could have put 3 more slides just with this, but at least to a bare minimum, use TLS encryption when talking, manage user rights and permissions, make sure to remove access to the control plane, limit and restrict as much as possible access to the actual cluster, and last but definitely not least, make sure that you update your OS and you update all of your security measurements. Again, you can go further into this by watching Brian's talk. And in the end, for us developers, we have also application level security, but that is combined with actual culture and way of working. Of course, you have the JVM and the Spring security, but on top of that, it is crucial to actually integrate this into your way of working and into your company's culture, which means that have at development level continuous SAST and lean scanning to make sure nothing that is bad ever ends up as a pull request to your development branch, and I'm talking about the master branch, not even in the development branch. And after you finish working in the QA phase, make sure to create the containers, deploy them in a testing environment, and do dust and penetration testing. But as interesting as this may or may not sound, everything comes at a price. And before going the route of on-prem deployment, you have to ask yourself, is this what I want to do? And here are some issues that we faced. Now, in 2023, it's hard for most of us to even imagine the first problem, but this was also the most important one. No internet access. Yep. The first step, not the only step, when creating an air-gapped environment is to remove the cord, or better yet, never plug in the cord. And without an internet connection, even installing Kubernetes, the cluster as an automated process was more gruesome than you even can imagine. On top of that, even the fact that we wanted to deploy our own solutions and do updates, do security patches, and the whole chain of making this happen was a head-scratcher. But this was non-negotiable, so we had to make it work. And these were just the first roadblocks in a long list that we need to tackle in order to actually end with a one-click installation. But after finding ways and tools to make that happen, we also had to tackle different environments, different hardware, because hardware agnostic is too much to expect out of any solution. The requirements that we had initially, or the conflicts, were huge for the standalone application, but even using this solution, it broadened our offer and our access to different hardware, but it didn't make it that it can run on everything. Also, of course, we have different requirements on a client-by-client basis, and the thing that killed us and we went and were revived and killed us again was storage. So I want to leave you with some key ideas. First of all, in relation with our duty as tech people, is to push migrating our legacy code. It is a must, and it needs to be addressed ASAP. Also, choosing an open and scalable architecture that is technology agnostic is the way to go. There are multiple ways to look at cloud. People tend to only think of deploying in an online cloud provider, but maybe that's not always the case. And sometimes that gets overlooked. Now, deploying cloud solutions as a product on-prem and air-gapped is really hard, but it's also fun and very satisfying. And last but definitely not least, if you have the opportunity to build a system from scratch, security should be baked in at every step. So with that in mind, you can choose. We can have some questions right now. Otherwise, we have the opportunity of having a booth and a full-fledged team of my colleagues here. Find us at the Cognite booth. It's right outside the restaurant. So if I'm looking and I'm thinking also about myself, let's have one question, then go to lunch, and then we can meet up afterwards. Any questions? Okay, everyone is hungry. Thank you.